Thomas, start whenever you want.
Okay. Hello, everybody, and yeah, I hope at this wonderful conference I bring you the buzz of the next year. So in the last session, I noticed nothing which I talk about is older than 3 years. Some tools are only 2 years and 1 year, so this might be the next buzz. That's me. We are from Endocode, Berlin-based company. I'm the CTO, and I'm doing system automation, DevOps. We all do the cloud, database, and thing stuff. Not really big data, but we are working in the cloud and building clouds for customers. These are our typical requests. So normally we work for CoreOS, for people who really have problems with all this new technology we present, and do consulting on that. So typically we fix problems in Kubernetes and then find stuff somewhere in the Linux system. So yeah, everything we publish is pushed upstream. So we found a bug in the Google SSH implementation. And this is a discussion how we pushed it upstream. So this is a security bug and public now. Typical things, some of the applications is breaking. Then we find it's not an application problem, it's a systemd problem. No, it's not a systemd problem, it's a journal problem. No, something in the kernel buffer is too small. We fix it in the Linux kernel and push the fix to the upstream kernel. So this is our daily business. And yeah, the agenda of this talk is what can we do with containers beyond Docker? And as I've heard a lot of wrong things about what containerization is, I added one sheet, containers versus virtualization. So this is not the same and should not be mixed, at least if you want to do real stuff in production environments. Then I will talk a little bit about Kubernetes. CoreOS is our partner. They are based in the Bay Area, make a new version of the Linux operating system, which is explicitly dedicated to run containers only. So they skipped everything from package management to configuration management and have containers only. Then I will show you what you should start if you plan to put an application into a microservice. So containerization is done a lot at the moment. Some people do it in development, some people do it only in production for some reason. And I don't know why people didn't get it into a full deployment pipeline, because the deployment pipeline itself is a complexity. I will show you what you have to do if you want to migrate from the typical virtual machine or operating system start point. We have a case study where we exactly did this. This is Immer. This is a Berlin-based subsidiary of Deutsche Telekom. They have been buzzed at the Mobile WorldCon in Barcelona as a so-called WhatsApp killer. I don't know if that's true, but they are doing serious business and they are using all this stack in production. Then I will summarize it, what is the success story, what have been the real challenges, and of course, what's missing in this ecosystem. So this is a table, virtualization versus containerization. So the containers are in the middle, and you see it's completely different on the isolation level. And typically, you can run containers only on the Linux operating system. Some people say, no, we have native Docker on macOS or on Windows. No, they inject a small hypervisor, which is too small to notice under normal conditions, but it is not native. It only can run native on a Linux system because it makes heavily use of Linux namespaces. And therefore, you cannot run foreign kernels, so you have to use the same kernel as the hosting system. You don't need to emulate devices. You can simply use a native devices, which makes it big different if you have, for example, fast network, software-defined network works well, and without any performance losses. You don't need this VirtIO thing, which slows down your big load applications, and you simply have everything native. And one thing is the root isolation, which was very poor in the older versions of Docker, is now implemented as a user namespace, so the root user inside your container is not the root user outside the container, which is a security feature. The only thing which I have marked red is if you have hard crypto or your private keys inside the CPU and you have a CPU cache, it will be easier than on virtualization because you only have to avoid one MMU instead of two to leak private keys from one container to another one. But there has not been a proof of concept. I did not have the time to do it. But all the proof of concepts you see for virtualization should also work with containers. So the next big thing, if you believe in Google cloud computing and the Googlers, and we have partnered with Google, so this is more or less a disclaimer, is Kubernetes. And Kubernetes is something, yeah, how you want to address it. It's a container orchestration framework. It's made simple. You simply can say start a container. You have replication controllers where you can start containers at large scale with one single command line as a kube control command, and you can run a lot of things. Kubernetes is a helmsman or governor. No, it's the same root linguistical as in cybernetic. And the main goal is that you manage applications. You don't want to manage nodes. This is a problem which you always have. If you have developers and testers, you should not be bugged by setting up nodes, installing hard disks, installing 20 disks for something and then run it. You don't have to care about it. You only have to care about your application. So this is a big picture. Here is a simple API, which can be a command line interface as kube control. And on the other side, you have the kubelets on your node, and all the things in the middle is done that your applications run seamlessly. They have a key value store. This is the most important thing. This is the second from above. It's the etc daemon. And the etc daemon is a distributed key value store and is guaranteeing that the state is unique in the entire cluster. But you can forget all the things. You have simply a client communicating to an API, and it's communicating to the container cluster. And it's run on nearly every Linux distribution. It's running on Ubuntu. I use it on Ubuntu every day, and you can run it on every major newer distribution. Even the older ones have it now. But there are some distributions which have been designed to run containers only. One of them is CoreOS. Their mission statement is they want to make the internet secure again, which means that they need a lot of stuff to secure the applications, the hardware, containers, and everything in between. And this is a typical stack. The hardware is at the very bottom. So you can ensure that the hardware has a trusted platform module. You can start a secure signed kernel. Then you have the OS integrity, CoreOS. CoreOS is kind of immutable operating system, so you cannot change the system disks of CoreOS. This is a feature, so you cannot install software the ordinary way. You have to use a container runtime, And besides Docker, there is Rocket, which is another container runtime, which is not even a year old, I think. And on top of that, you have the container management software. Rocket could be replaced if you don't trust everything on this picture by Docker. So this, they made Rocket more or less compatible to Docker. Even the repositories or registries, how they call it, are the same. And this is the entire ecosystem. So this is a complete sheet of new buzzwords with symbols. I mentioned CoreOS, Rocket. They have Claire. This is a registry. A registry is where you put your images. So Docker Hub is the most known registry. But there is a public registry, Claire, which is, has implemented a feature that it scans every container against the CVE records. So it scans every container for security bugs. And this is important for container lifecycle management, because if you look into the Docker Hub and put the things into Claire, you find that 60% of the images yet have the ghost bug installed. So this is quite a heavy bug in the DNS system of the glibc, and can be exploited from outside. And 60% of buggy images on a registry creates a lot of distrust on the entire ecosystem. So the recommendation is not to use, under no circumstances, some unknown images from any registry, but rebuild them from the Docker files, which is also always possible. It's a little bit time-consuming, but you can then check that everything is up to date. Don't use unknown images. You would not start an unknown exe on your system if you would use this crappy operating system. And you should not use unknown containers on your in your infrastructure or on your laptop. I mentioned the etcd. This is a distributed key value store. It's very similar, I think, like the Kafka key value store, and has the same philosophy in mind. So, and don't ask me about Kafka. So this is a very simple key value store. Then you have Canal. Canal is a joint project, less than 4 weeks old. There was an OpenStack project with this little cat. This is Calico. And there was a network layer, Flannel, directly built into Kubernetes. And they merged into Canal. So this is OpenStack power for networking joined with the simplicity of Flannel. I mentioned Kubernetes. This is a sign of Prometheus. Prometheus is also from Berlin. So SoundCloud started it, and CoreOS took over. So they are doing it now on their own stack. And yeah, there is another thing, a little thing. OpenStack can be run in Kubernetes. If you use CoreOS on your bare metal hardware, it takes 15 minutes. Not 15 weeks or 15 months to set up a complete OpenStack cluster from the container. So this project doesn't even have a logo. This is Stackonitis. This is OpenStack inside Tectonic, which is a CoreOS project. And last week, they announced Taurus, which is a storage product. So they address the problem of distributed storage in data centers. And Taurus is so new, it does not even have a logo now. So this was a buff thing. And now what real-world applications can you do with Kubernetes and what you have to address in the real world? And as you know, almost no project starts in a greenfield. Even if you are a startup or a spin-off of a big company, you have something to respect. You always have some kind of technical debt. The environments are not made for microservices everywhere at the moment. And this means you have to do something that your application is really a microservice, that your application fits into containers. I assume you have several layers of an application. Normally, you think you have a 3-tier system, but you actually have, at a minimum, 5 or even more tier system. And starting from the top, normally you see something for a web application, which is a load balancer. And then you have your web page, the web portal, which looks to the outside, which is completely stateless thing. Then you have some cache, like Memcache or here Redis. And then you have the business layer, where where main applications are, notifications, the user profile, everything which is processed, which makes your business logic. And then you have something which you really care about. This is your storage layer, so your persistent state, where you keep your state. Storage, the SQL, the NoSQL DBs, but also the messaging systems. It doesn't matter if it is RabbitMQ or Kafka, you have some state inside here. And you should, if you start designing microservices, separate this very carefully. So on the upper 4 layers are completely stateless. You should not have a database in your web main app. This is something the LAMP stack tries to force on you, that you have a database in Apache and PHP applications, the same thing. This is, on scale, this is fatal. You cannot really use it. The cache can be reconstructed, so I consider the Redis cache or any other cache more or less as stateless. The web portal does only a view to the outside world and should be stateless. The load balancer should be stateless, and this is a little bit contradiction of some old philosophies. If you have EGB servers where the session was so expensive that you had to stick a user to a special EGB server. This is not a good choice anymore. So the result of the thing is you should try to make everything which changes rapidly. So your application, if you want to do a deployment every 20 minutes, should be stateless. And you should care about the things in your database. If you are running it in a cloud, Amazon, Google Cloud, whatever, you should use, at least where it is possible, the storage services of the cloud provider. This makes much less effort than setting up your own, let's say, MongoDB server and use it in production. But if for some reason you have a very special database, if you need some tweaked performance, or if you have to run your own MongoDB because the MongoDB in your cloud provider's version is too expensive, or you need special features, you have your own thing, you can put it into dedicated machines, run it under Kubernetes without replicating all the application on top of it, and run it as a container in a replication controller with a replication number of 1. The disadvantage of these databases is every database has its own way of replicating data. And therefore, you have to care about every database individually. This is a little bit of work, so our first recommendation was shrink the number of databases to the minimum. There is no real need why you should have a Postgres and a MySQL and a lot of other SQL databases in parallel, so it's always a good advice to minimize the external dependencies. Yeah. And what you see here is you have normally a heterogeneous environment. Every real application has different things, different messaging servers, so you have normally a full stack of different things, and you can isolate them in different containers. What you also should think about that Docker is, if you really look into it, it's a kind of stacked archive, and you can use this archive as your standard deployment format. There is no need to do RPMs and configuration management in parallel to containers and microservices. The only people who want configuration management in containers are from companies who want to make you use their tools, and this is not necessary. So think about your deployment chain automation. If you have not done many things in this area where you say, I want to automate my deployment, probably containers will not solve your problem. And there's no need that you add containers if you did not do this thing right, because then you have another toy to play and to fiddle with, and this does not make your life easier. You should first at least plan to run everything in an automated system. So I mentioned these things already. Migration. What is a typical thing of a migration? Normally, Docker and all the others recommend to have only a single process in a container. But what if your application consists of a dozen processes or more than one? Then both Docker and also Kubernetes have a concept of aggregating containers, that they can share the network, that they have common file system, and that they have the same fate. So they are created together, they are running on the same node, which is a guarantee, they are terminated together, they have a single network address, and this is interestingly, they can share volumes. So everything, and volumes also means, for example, sockets. You can expose an HDFS file system as a socket to a different container this way. And so you change your virtual machine cluster into pods running onto Kubernetes. And then, important, I stress it again, you separated the kettles from your pets, so the stateless containers from your databases. And your configuration management is not completely gone away, but you should separate build time and runtime, that you simply build containers on a machine, test them automatically, push them to a repository where they are scanned for security bugs, and then you can roll them out automatically in production. So if you have state, you have to care about it, but the general mindset should be that everything should be an ephemeral deployment unit. Even the database could be ephemeral, but the storage below, together with replication, guarantees that you do not lose your data. Okay, you can more or less, if everything is stateless, internally you talk with a REST API, and you can connect all the front ends and to the rest of the application. And the deployment pipeline takes care of that. You can give environment variables and configurations like database passwords as secrets into the container. So normally you have a big problem if you want to run production with different database passwords than testing and development. Kubernetes has a concept of a secret where you simply can put a secret into the Kubernetes cluster. It's completely encrypted. It will be encrypted in the running container, and it will be exposed as a file system, but it is not written to hard disk. It's on a RAM disk, so that you never expose your passwords to a file system outside your Kubernetes cluster where somebody could find it in a cache or something else. Yeah, you could use normal logging. For large-scale things, we recommend Prometheus. And this is because normally you need Prometheus is a very simple monitoring system. You cannot put very sophisticated things into it, but only values. But with a huge number of containers, it's exactly what you want. So I already mentioned this. And again, this is the desired architecture. So try, in the first step, to identify all your applications that they fit into this picture and make them available as stateless containers. Case study here is Immer, which is a new messaging service. It's bound to your telephone number. You can take a normal phone call on a completely different device. It can be a WebRTC device, so in your browser. You can use it on your phone. You can use it on an iPad or wherever. And it's going productive this summer and will be rolled out in different European countries. This is a telecom subsidiary using Google technology in the Amazon cloud. And this kind of, you see everything is spread, best practice if you have the main parts open source. So what did we do with the application? So we had found every programming language. We heard about it. So Java is very popular, Python is very popular, Node.js, Ruby. They have different challenges. The easiest thing we found was Java with Spring Boot. And why is it so easy? Because Spring Boot has the unique property that you can override the properties in property files on the command line of the Java virtual machine. So you can definitely pass parameters quite easily from the Kubernetes environment to Java. Python also works well. Packaging works. And yeah, a little bit hard was Ruby, because the Ruby gems have a problem that you always try to install a compiler on the system. So we are a little bit fighting with it. But there is a solution on the horizon that you can use traveling Ruby to create a static binary that you can run without even having an operating system in a container. So the Ruby version hell is this RVM stuff, so this bloats your containers. It's never up to date, installs a lot of things, and we try to fiddle around with this. So, what did we learn? So we are preparing for a security audit, and in a telecom environment we have to do this anyway. The separation is very easy to do. We had a little bit a learning with Docker files, so effectively Docker creates a new image for every line in a Docker file. If you don't do it right, then you wait forever until a Docker file build is done. So it's kind of inheritance. If you do it right, then you only change the last line in your application, and then it's quite fast. If you do it wrong, you have to install the entire operating system, and this takes forever. And KIO is the commercial version of Clay, so Clay is completely open, so this is a registry scanning for CVE, against the CVE database for security, and this is good for container lifecycle monitoring. If you don't have container lifecycle or any lifecycle monitoring for your applications, then you probably have some security problems. Okay, the outcome was we have now a scalable and a cubified application. And this was a service architecture they always wanted to have. And now using it in a new project, it was quite easy to enforce it and to implement it. Everything is standardized. Yeah, we have used everything as if we had influence enough to use the cloud providers' databases, and everything seems to work. For business value, we are deploying now quite fast, so an update takes only minutes. And not hours, and we don't have to call anybody, so at the moment we are passing it to the very small operations team. simple. And yeah, I managed all this. Yeah, this is again about configuration. Let's talk about what's missing. You always want to have leaner containers, and lean makes in a container normally you have parts of the operating system. So this is a kind of heritage of the thinking that it was intended like a virtual machine, but you don't actually need an operating system in a container. You can, most people don't even notice that you can define a container from scratch. And if you can create a static binary which does all your requests, then you can have a single application without even a glibc inside the container. We have an example how to do it with Go. It's quite straightforward with Ruby. Straightforward if you fight with all the games. And yeah. This is where we intend to go. And if you don't have parts of the operating system in the containers are more secure than without. So it's quite hard to imagine something where you have a problem where only one single static process has a security problem in the container. Yeah. Yeah. One last thing about the databases, best practice, if you do everything automatically, you should notice that some frameworks enforce database migrations. So you have to handle it, you have to tell it to the team. There is no rollback in this philosophy, so the mindset always rolls forward. This implies that you have to test it carefully with the right database scheme if you're on an SQL side. And you have to look how to get it. There are solutions behind it. For example, use different databases. So Crate.io is a SQL database based on Elasticsearch, which is very simple and could handle it without having a scheme inside the actual data. So yeah, container-focused languages I would recommend. Yes, and does it really scale? Actually, we will see. I think we will scale it by country, starting in Eastern Europe, smaller countries, and roll it out if it is successful in Germany. You have to be a little bit careful about single-tenant and multi-tenant use cases, because if you run if you have private keys involved, then running an application from different teams or different countries on the same hardware could be a leak. But if you really need it and want to use Rocket, Rocket has a unique feature. If you want to improve the isolation, Rocket can, even like the versions for other operating systems, can start a tiny virtual machine which gives you another level of isolation. Yeah, and the good thing is, if you don't trust all these cloud providers, you can run it on your own hardware. This is our example for FOSCON. So we had 4 Raspberry Pis, and the only problem was to get it into an airplane and explain to the people that this is not a time bomb. And Kubernetes is terribly slow, but it works on Raspberry Pis. You can look it up. If you want to run it in your data center, there are even data center providers at the moment who are offering in Europe Kubernetes on bare metal. We can connect you with them. Then you have to implement providers for storage, which is quite easy because you can use iSCSI and things like this. Network really depends on your local environment. Firewall providers, there are examples for firewall providers where you could use, I think Zalando has an example how to configure F5s with a queuing system, and then it works. But you have to do it. It will not give you the same comfort as in the clouds if you don't implement these providers. So if you want to have more from us, we have a GitHub account where we publish everything. We give trainings. We do quite regular blogs on everything which is open source related in our company and the world. And yeah, if if you want to test it without hassle and quite easily, you can easily use it on the Google Cloud platform, and with these links you get some $300 on cloud time and computing time, and you can have even 200 more if you test it. It does not influence where you run it later. So most customers of us are using it in the Amazon cloud, which is a little bit sad for Google, but they don't have a data center in Germany, and most customers require a data center in Germany by law or by the internal politics. And maybe we will have the luck that we see a data center, Google Cloud data center in Germany. So thank you very much, and if you have questions, please.
All right, thanks, Thomas. Do we have questions here?
Thanks for the talk. Could you explain perhaps a little bit how you, in the best case, handle configuration for the containers? So let's say, for example, a password or a private key which you need inside the containers. You should not bake it into the container, I assume, but where does it come from?
It comes from the Kubernetes secrets. So this is a special concept, and you should not put it into the configuration itself. You should not put it into an environment variable. You should put it in a way, in a secret, Kubernetes secret is a YAML file. You can have a different secret with the same name in testing and production, and then you pass a secret and get access to the database. And from inside the container, it looks like a bunch of files in the file system. Or if you, on a big scale, you can use solutions like Vault if you want to solve the authentication problem. But this is a complete bigger story. More questions?
All right, let's thank Thomas again.
Okay, thank you.